So hi, everybody. Welcome to the first webinar and what I hope will be a recurring effort from the 4D team. And today I'd like to talk about how to connect Tableau to 4D. And I will walk you through a step-by-step process of how to do this and show you a limited demo of some cool Tableau features. So we're recording this for our purposes, for learning purposes, and also if you're interested, you can request a copy of this recording from myself or from your sales representative. So there'll be a QA section at the end. So please feel free to click on the Q&A button and ask your question, and I'll do my best to respond live. And if not, we can take it offline. Okay, so let's get started. So what is Tableau? Tableau is an interactive data visualization software package that allows for data scientists, business analysts, and business intelligence professionals to do what they need to do. And one goal of these professions is to create relevant statistics from large data sets to present them in a visually appealing manner. And as you can see from the video here that I took from Tableau's webpage, it does that pretty nicely. And Tableau, what's interesting about Tableau is that you can connect to many different data types, either natively through Tableau, through their native connectors, text files, cloud-based databases, or any database with a REST interface. So first, a word about myself. My name is Will Taylor. I'm a Capricorn. I work for the 4D team as the TAM, Technical Account Manager, and I head up the professional services team for all projects in the US. So, as I stated before, there are many ways to connect to Tableau data sources. Since Tableau does not have a native 4D interface, we will need to access that data somehow. But how can you connect to 4D? One way you can do this is using the Tableau Web Data Connector. The Web Data Connector is a middleware layer that sits between Tableau and 4D. And this is an application that's running in a Node web server. And it runs JavaScript code that's called by Tableau that requests data from data sources like 4D, binds that information back, and then sends in its appropriate way and sends it back to Tableau. So today I'm going to show you how to set up your 4D, which you probably already know. I'm going to talk about how the Web Data Connector is set up. I'm going to discuss ways to set up a REST API from 4D so that your node is able to access your data. And then I'm going to show you how this all works in Tableau. So let's get started. So the data that I'm using today comes from the New York City taxi cab data. So I didn't know this until I started this webinar, but New York City logs every single fare by every single taxi and provides people with that information freely on their website in a comma separated value format. So that sounds pretty good to me. I like that. So that's the data location, and there's the data explanation. And this is what the data looks like. And as you can see here, this looks like a standard Excel spreadsheet or pages with a bunch of information. You got pickup time, you got drop-off time, you have location IDs, you have so pickup location, drop-off location, toll amounts, etc. So this is a pretty rich data set. So it seems like it's a pretty good one. And it's pretty easy to understand because we all take taxis. And as some of you know, I don't have a car, so I take a lot of taxis from previous demos. So first thing I do is I create a database. So I take the information, and this is a pretty simple data set. You have a main fares table, and you've got a couple supporting tables for their many-to-one relationships. But the main information that I'm going to want to talk about today is the fares table. And this is where the main data is going to come from that we're going to pull from 4D into Tableau. And I like this table for many different reasons. I understand fares of taxis, and I can get, and also the data set is complex enough to have all different types of data types. As you can see here, we have alphanumerics, integers, booleans, date times, reals, etc. So what I did, excuse me, is I pulled the information from the CSV file, put it in the fares data, put it in the fares, and then I'm done. So just as easy as that, using the built-in 4D tools. So now that we have the data set up on the data page, we need to figure out how to set up the web data connector. So Tableau and their web data connector, Tableau has a web data connector that's really, or Tableau's web data connector is very well documented. And you'll see on their documentation page that you have to do two things to set up a web data connector. You have to set up an HTML page that's able to call some JavaScript and a JavaScript file to define what Tableau needs and how to get it from a data source. So the first things first is we're going to talk about the HTML page. The HTML page is a really simple HTML page that gets loaded up in Tableau itself, as you can see at the picture below, has a button. It's called Submit Button, and it sources a JavaScript file called taxidata.js in this case. And that's pretty much it. So that's how you're able to initially connect your Tableau to the web data connector, is through this web page. Now onto the JavaScript file. So this is where the real heavy lifting happens. And the JavaScript file has 4 parts. You have to register the connector. You have the button code. So what's the action listener on the button? When you click Submit Button, the Tableau data definition or schema, and the 4D data binding. So the getting and the binding of that to the schema. And I'm going to go into a little bit of detail here. But if you have any questions about the Tableau web data connector itself, I suggest that you have a look at their have a look at the documentation. It's very complete. So the registration of the connector. So this is the code that you need in Tableau, and this is the registration of the connector. So you make a connector, and what this code does is it creates a connector object. It defines two placeholders for functions, one get schema and one get data. And get schema will be where we define the column headers, or the type of data that we'd like to see in Tableau. And the get data will be the code that we will write to get the information from our 4D REST API, and then bind that information to the schema. And then we register the connector, and that validates the connector object before initialization. And remember how we added a button to the HTML page? Well, this is where we create an event listener that responds when we click that button. What's done here is that we have the first line, the document.ready function, runs this code when the page loads. And when we click the submit button, it defines the connection name, so the connection name that Tableau will see, and the submit function, and it calls a submit function that sends that information to the connector for validation. And you'll see kind of how this works at the end. Well, you'll definitely see how it works at the end. So we have the connector and we have the button. Now, as I said, we're going to define the schema, the get schema, and the get data. So the get schema defines the column headers of what will be pulled into Tableau. And these column headers are represented by an array of objects. this array of objects has, each object in this array has an ID and a data type as defined by the data type enum in the Tableau Web Data Connector. And as you can see here, so if we just take a couple, we have the pickup time that's defined as a date time, the pickup location ID as defined by an int, as that's how it's represented in the data, and a total amount, which is represented by a float. So that's how we define what Tableau will receive, or the type of data that Tableau will receive. Now, the actual data that Tableau will receive is defined in the getData function. In the getData function, you make a request to the data source. In this case, it's localhost tabsphere, and a little bit more complicated. I have to pipe it through a proxy in order to bypass some security stuff since I'm running it on localhost. But so that's just for this demo. And then this returns. So so what I do is I request this information. It gets the information it gets the JSON information back, and then what I'm given back is a large JSON object, and inside the JSON object is an array of JSON objects. And what I have to do next is loop through all of the responses and put them in the appropriate, and associate them to the appropriate column header. Like here, I put the vendor ID with vendor ID and the pickup time with pickup time. So that's what I'm doing there. So that's pretty much it for the Web Data Connector, for the Web Data Connector. And so that's pretty much it for the Web Data Connector. So I've got the data in 4D, I've got the Web Data Connector, and now I need to set up a REST API in 4D. and I want it to be, when I call 127.0.0.1/tab/fares, I want it to return something that looks like this. So that's the information that I would need from 4D to be exposed to the Web Data Connector at that endpoint. Okay, as you can see here, it has the same sort of information. So it's an array of objects. This is just one object, but you can imagine there being many. And then you would associate that to an appropriate column header, or to a schema type. And so here's a standard way of creating your own REST interface in 4D. And here's the code for my on-web connection that I'm using. It's called OWC. So it looks at the first parameter, which is the payload after the 127, after the URL, or after the address, server address. And then when I call 127.0.0.1 tab fares, when I hit that endpoint, it's going to call OWC tab. And that's where we're going to do the main heavy lifting. And here's the code that I wrote for OWC tab method. As you can see, I'm using Orda. And what I'm doing is I'm getting due to the massive amount of information I'm just getting from one day, I'm querying the table for the pickup date for the first day. And I'm packaging that. I'm creating a JSON object, and I'm packaging it up in the way that the Web Data Connector wanted to see it based on the Web Data Connector's programming and what it expects to receive. I'm stringifying it, and I'm sending it back from the web server. That's all I'm doing. It is really simple in using Orda, as you can see. Okay, so that was the traditional way of getting data from 4D. And that way will continue to work in the future if you've done it that way. But in version 18, you can now do this without any code with a new REST interface that is at our disposal. So I invite you to have a look at the documentation for the REST interface. It's located at developer.40.com. And in it, you will see that you can expose a REST API, a REST interface, in 3 steps and without code. So that's pretty awesome. And so the 3 steps are, you have to expose your REST server in the database parameters, the database settings. As you can see, there's a new, under web, there's a new location for REST resource in V18. And you have to expose your REST server. And also in the inspector, in the element inspector in the structure editor, you can expose a table to a REST resource as you wish. So by just clicking that button. And you can expose at the field level. So you can have, you can say which fields you'd like exposed and which fields you would like to be not exposed. And that's it. So that's really interesting, and that's something new that you can only do one second. I see people are using the chat. Can you ask in the Q&A? Sorry, it just creates a lot of, I see a lot of things going off. I see it's probably an exciting topic, and I'm for sure willing to get into it afterwards. So when you, so now we have the data, the database setup, the web data connector, and the REST API. And for the sake of this demo, and because it's so much faster, I'm going to use I'm not going to use my standard way of doing it. I'm going to use just a direct link into the REST interface. So now on to the Tableau portion. So now that we have it all set up, I'd like to see that it all works and how it fits together in Tableau. I mean, we have a lot of disparate parts, but how does it actually work together? You're probably asking yourself, and that's totally valid. So from Tableau, you click on the web data connector. So you see which type of data file you want to connect to. You can connect to many different files for free, and I'm using the Tableau Public, which is the free version. So I'm going to connect to the web data connector. When you connect to the web data connector, it prompts you with a browser. You point it at I point the URL to the HTML page that's hosted by my web data connector that has the button and sets up the logic for the web data connector. Then I click update and I get the data from 4D. Then I click submit button, and then then it provides me with an update now. And then that provides me with all of the information that I will be receiving from 4D in this sort of environment. So I've been talking a little bit about many different things, and I'd like to show you kind of how this works all together. So, and I'd like to show you some cool graphics that you can make really easily, and you can see why Tableau is a really nice tool. So what I'm going to do is I'm going to exit out of this. I have that running. So I've got my node running, my node web server running. I've got 4D server running now. Okay. Very good. Version 18. And I'm going to load up Tableau. So as I said here, I'm using the Tableau Public, which is the free version, and it doesn't have all the native connectors. which it works for me because I'm interested in the Web Data Connector. And I load up and I point it to my Web Data Connector, get taxi data, click that button like I said before. Hope it works. It seemed to have worked. Very cool. So now I'm going to click the Update Now button. And what this is going to do is this calls the Get Data function. So as you can see, my server's starting to work behind there. And what I'm doing is I'm getting all of the data from January 1st, which is, well, we can see, I forget how many lines, how much data it is right now. So that's my data viewing screen. And I'm going to go to a sheet. And in a sheet is where I'm going to create my graphics. And this is my sheet. So these are my dimensions. I don't have a lot of data. I only have 3. Oh, I can go back to the data source. Let me just go back to the data source really quickly. So I only have 3 elements, or 3 things that are being pulled over. I showed a more complicated Web Data Connector before. So I have the pickup time, the pickup location ID, which doesn't make a lot of sense until, well, the next demo, and the total amount. So that's the fare amount. Okay, and this is all the information from the first of January 2019. So if you went there to watch the ball drop last year, and you took a taxi after, you're in this. So I'm going to go back to the sheet. It's going to load the data up in the sheet. Cool. So number of records. So let's just see how many. So there are, sorry, it's 189,000 records that I'm talking about here. So I can just remove that maybe. Go back. So an interesting graphic would be something like the amount of money made per hour for pickup location, for pickup time. So how much money was made at 1 a.m. could be an interesting graphic if you were interested in things like that. So what you do is Tableau is really user-friendly, and you're able to just click and drop. It's like pivot tables, only more complicated. It's really interesting how to use it, and it's really a rich, oh, that's not what I want. It's a really rich tool. So I'm gonna go pick up time. I'm gonna click on pick up time. And I'm gonna go, so that's on the column, and on the rows, I'm gonna say, maybe number of records. And then rather than the year, because that doesn't make a lot of sense, because I'm looking at a day, I'm gonna look at the hour. So here I have the amount of, this is a non-continuous graph. And so, I mean, it's displayed as a continuous line, but it's non-continuous. It's a discrete graph. And as you can see here, we have, so every hour, so at hour 1 or 1 a.m., there are 15,000 rides that are taken in New York City at that time. Which makes a lot of sense. People finish up with their party, and then they head out, they head home. And then it drops down, and then it picks up again. So this seems to make a lot of sense based on my recent New Year's Eve parties. So that's a really cool thing that you can do to create this, to create a nice graphic really easily from 4D. Another thing, but you're saying to yourself, you could do that in 4D really easily. And yes, you can do that in 4D. But this is the tool that people like to use, and this is the tool for data analysts to use, and they like to make even prettier graphs with their own, as they wish. So another thing you can do to make this is you can create, and you can have disparate data, or you can have have data from different locations and you can bind them together. So as you see here, there's this pickup location ID, and in the data, there's a pickup location in the data that was given from the New York City website. There's a pickup location ID, which corresponds to a specific type of file called a spatial file, which contains cartographic information like latitude, longitude, and just information that you can make a map. And then it also says where the location is. So what you can do here is you can join two data sets together here on the fly to make it look a little bit more interesting. So I'm going to pull in a taxi zones.shape file. And here, Tableau knows that I'm trying to join two sets of data, and it proposes an inner join at first, which is fine. And it lets me say on which field I will be doing the inner join, and from where to where. So on location ID, on the ID, I will do the inner join. So now I have these two sets of data here, the two connections, and I'm going to update it again. And as you can see here, so from the pickup location ID, I have 83, right? And 83 corresponds, oh, sorry. Here, let me make this bigger. 83 corresponds to Queens, Elmhurst, and Maspeth. The shape area, shape length. So that's things that Tableau knows. And then I will be able to use those things to create an interesting heat map. So I'm going to open up another sheet. And with that information, I'd like to see. I'm going to load up the information into the other sheet. Okay, and just by dragging and dropping and clicking, I will be able to create a really cool heat map. So I just drag that on there, and that's New York. A little bit bigger in real life. And then I can add the zone in there. So I can say, okay, those are the different zones that we have. And I can add another dimension, which is the number of records that per zone. So I can have that there, and I can add color to this. And this, just by a few clicks, I'm able to create this really interesting heat map. And this is the legend here. I can edit the colors. That's cool. That looks great. So from one is yellow, right? So there aren't very many people taking taxis there. But there are a lot of people taking taxis to JFK, so either a lot of people leaving or getting away from New York, or going to New York. And then we have a bunch of taxis here that are happening on that day. So as you can see, Tableau is a really cool way to be able to create dashboards, to make really nice graphics that people that know what they're doing with data are able to take it and slice and dice it and make really interesting things and learn a lot from the data. So those are the cool things that I wanted to show you about Tableau. I'm going to, how do you get back? There we go. So that's that. I'd like to thank you all very much for attending this first webinar, and what I hope to be many in the future. After the summit, I hope to start this up as a regular thing. We have this tool now. I think it's really cool, and I think it's a really great way to ask. And feel free to reach out to me, wtaylor@40.com, if you have any comments, questions, concerns. And I hope to see you all in Chicago. So thank you very much, guys. I don't know how to end this. So do I just quit? Okay, thank you guys. Take care. Bye.